Hey everyone, in this video we are going to start with our first formal introduction to adding and subtracting rational expressions. We are doing this in algebra and we are using linear binomials and quadratic trinomials, quadratic binomials, and such as our denominators. But we're going to start a little light. We're going to start with the diet version, and it's a little bit of a combo of fourth grade and a few X's in there, but we're going to start pretty light with just simplifying something like this over here. Now, we had a little discussion before this recording about when we are trying to add or subtract fractions, that even though in our heads, adding and subtracting might seem like that came before multiplying and dividing. Adding, subtracting, easy. Multiply, divide, hard. The reality is when it comes to rational expressions, there's more work involved with adding and subtracting. And it's a little bit more simple and less complex, less complicated with multiplying and dividing. And that might not seem reasonable. It might not seem true, but that is the case. So if we want to add or subtract fractions, we need to find a what? We need to find a, anyone before I put the answer down? What do we need to find before we add or subtract fractions? No one wants to say out loud or being bashful?
The least common denominator.
Good. We need to find the least common denominator. So I just have this little note written. If we want to add or subtract fractions, we need to find a common denominator. Denom. Now it's better if it's the least common denominator for sure, because you don't want things to get too big and out of control. So I see what some of you wrote in the chat, because I did ask you, what did you get for your denominator? And I'm just going to peek again. And I do see a few. I see a few people putting 36, and then I see one winner with 36x. So if that x were not there, you guys would be right with that 36. But Adriana, give yourself a high five. It is 36x. Now let's look at this. Let's look at this with a little x-ray vision. I've always given, one day I'll make like a more proper video. Maybe I'll pick up some Skittles today. And I use this little Skittles story. I don't remember. Did I do the Skittles with you guys already? Maybe. But I always do a little Skittles story. So I'm one of 4 kids. 1, 2, 3, 4 children right here, okay? I'm one of 4 kids. I'm the oldest. I have 2 brothers and a sister. And my dad on Sunday mornings used to always go to the corner store, and he would pick up like the Sunday paper, like the big newspaper on Sunday that comes with all the inserts for the stores and things like that, what's on sale that week and whatever. And he would get a bag of Skittles, because we loved Skittles. My dad would get a bag of Skittles, and he would split the Skittles among the 4 of us. So he would get little plastic, like little kid drinking cups, right? And he would 1, 2, 3, 4 cups, and he would give each of us some Skittles. And we were kids. So what did we do? We immediately looked at like what flavors we got, and then we got annoying and jealous. Like, she has more red Skittles, or he has more green Skittles, and why do I have only yellow? Or, I want the yellow, and blah, blah, blah. So my dad would take his bag of Skittles. And this is a true story. Okay. And basically what my dad would do is kind of like finding common denominators, where pretend this is my cup of Skittles, and all I got was 1 3 Skittle. This is my brother's cup of Skittles, and he just has, let's just even switch the colors. My brother has 1 X Skittle. Next over here, 18. I got to break down that 18 though. Not prime. Got to break down that 18. So what does it take to make 18? Well, 2 times something. 2 times what? 2 times...
No.
Good. 2 times 9. But 9 is really...
3 times 3.
Good. So this is my other brother. He has a 2 Skittle, a 3 Skittle, a 3 Skittle. And over here, my sister, she has a 36. So 36 again is even. That's 2 times something. 2. 2 times what? 18. But 18 is 2 times what? 9. But 9 is really 3 times 3. So these are what we have in our cups. So my dad has his bag of Skittles. Now he's the one who's working. We're just a bunch of little kids. So my dad is like, all right, let's figure out what it is that each of you needs. What is it that each of you needs so that you all have the same thing? Okay. So here's my fraction bar again. In our numerators, this one was already a 2x. This was already a 5. There's my minus sign. This was a 7. And this was, and that was plus, and x. So my dad will give each of us from his stash of Skittles, his own bag, whatever we need at the bare minimum. He's dad on a budget. He's got 4 kids, right? Got 4 kids. You can't just be like, oh, everyone gets a bazillion Skittles, so you just all shut up. No, no, no. He makes sure we all have just enough so that we have the same and we could quit being annoying. So let's see. Maybe my sister, we start first. She's the youngest. She has 2 2s and 2 3s, but she's crying over here because she's jealous of something. What's she jealous of? Who has something that she wants? This is May. This is my brother Matt, my brother Dan, and my sister. Is she jealous of me? I have 1 3. Is she jealous of me?
She wants an X.
She wants what Matt's got. She's like, what? Matt has an X Skittle. I want an X Skittle too. All right, so if we give her an X Skittle, anything you put on bottom, you have to also put on top. She already had an X in the numerator. Don't worry about the numerators. So my dad gives her an X Skittle. So now she has what Matt has. She was not jealous of me. I had a 3. She was like, I have 2 3s. I don't care. Is she jealous of Dan? Dan has a 2. She has 2 2s. She don't care. He has 2 3s. So does she. She doesn't care. So now she has everything. She's like, I'm gonna eat my Skittles. Okay, she's happy. Over here, what does Dan want? I have 1 3. He has 2. He doesn't care. He also wants what Matt has. Matt has an X, right? So my dad's like, all right, here, you get an X Skittle. But whatever you do on bottom, gotta do on top. Is he jealous of Michelle?
Yeah.
Why? What does she have that he doesn't have?
She has an extra 2.
Yeah, he's like, well, Michelle has an too. And my dad's like, oh, shut up. My crybabies. What a big crybaby. Here, shut up. Have your 2 Skittle and get out of here. All right, bam. Now Michelle's happy and Dan is happy. All right, Matt's turn. Everyone was jealous of Matt because he had an X, but now he's like, now all I have is an X and everyone's got everything else. So the 2 Skittles, he doesn't have any. Dan and Michelle both have 2. So you get a 2 Skittle on top and bottom twice. Oops, oops, oops. And then on over here, 2 and 2. Okay. And then what about the blue 3 Skittles? He needs 2 of those too. He's still crying. And if you're the oldest child, you know. You always start with the youngest with making sure they're good. And the oldest child, we're last in line, right, for that? So I'm the last to go. I'm jealous and crying over here. I'm 6 years old. I'm like, but I don't have any of those things. All right, here. You get 2 Skittles. You get an X Skittle. Because we need a common denominator. That's in what's inside our cups. Now, do I get 2 3 Skittles because everyone has 2 3s? My dad has to give me 2 3s?
He needs to give you 1 more.
He needs to give me 1 more. And that's something important when we're finding common denominators. A lot of the times you're going to see with these rational expressions and this heavier factor stuff that people try to give too much. Okay, because they're like, oh, that one has 2, so let's give this one 2. If you already have 1, you only need 1 more. Remember, you're a dad on a budget. You got 4 kids, okay? You can't go crazy. So I need 1 more and 1 more. Now, now we all have the same thing in our cups. We all have the same Skittles in our cups, and we could quit crying and complaining. But let's think about what it is exactly in our cups. 2 times 2 is 4 times x. 3 times 3 is 9. And what's 4 times 9? Good, 36, not all at once. Oh man, 36x. Now I showed the finger trick of multiplying by nines the other day. I don't know if everybody knows it. Can you raise your hand button if you know the finger trick for multiplying by nines, the hands and finger trick? 1 person, 2 person, 3. All right, well, I'll show it just in case again. When you multiply by 9 and you look at your hands, okay? I'm doing 9 times 4. You're going to put down your 4th finger. So it's 1, 2, 3, 4. Boom. And then the number is the number of fingers before, 3. And then the number after, 6, 36. So 9 times 4 is 36. Whee! Okay. So 36x. There's your common denominator. Don't try to figure it out in your head if you don't know how. You break down the numbers and you could get it that way. Now, I know this might look crazy. I picked a big, crazy example. But
I have a question because like all of these circles are like messing with my brain. So the first fraction of 2x over 3, you multiply that by x.
so look at what you're really multiplying by looking at the numerator. Ready? Which ones are circled? X, 2, 2, and 3. Well, 3, I always start, I save the 2's for last. So I start with the 3. 3 times 2 is 6. Times 2 is 12 times x. So truly, you're multiplying on top and bottom by 12x.
Okay.
Next, save the 2's for last. 3 times 3 is 9. Times 2 is 18. Times 2, 36. So this, you're truly multiplying on top and bottom by 36. Next, 2x. You're multiplying on top and bottom by 2x. Last, just the x. But what this does for us is it breaks it down into little parts. And like I said, I picked a bigger, crazier numbers just so you could see a lot of things happening in this warm-up, okay? So my common denominator across all 4 is going to be 36x. Here, 2x times 12x. What does that give us?
24x over 36x.
Whoa, whoa, whoa. What's x times x, ladies and gentlemen?
24x. Wait, sorry.
Yes, 24x squared. 24x squared minus. All right, 5 times 36. I've shown you my trick for 5 times 36. Does anybody remember how to multiply by 5 trick that I showed you? Anybody remember my trick for multiplying by 5? Here's the gold. Instead, without a calculator, my boo-boo bears, okay? We multiply by 10, and then we divide by 2 in half. 36 times 10, 360. Divide by 2, half of it, 180. Or when it's even, divide by 2 and then multiply by 10. We can practice that in the future. So minus 180 plus and plus 14x minus x squared. And then we just combine like terms, maybe put the top in order, and we're done. So 24x squared minus x squared, I might write 23x squared, 14x, I'll write next because it's my linear term, minus 180 all over 36x. If I could reduce something from all the parts, I could do a super pretzel. It kind of looks like a peacock. You could do that right over there. Doesn't look like it. If I could factor the top, I would try. I'm not going to try for this example. And that's how you would consider a problem like this. But now let's look at something a little bit more algebra 2 per se. Example 1. Here we have this example, and what we want to do with this is add. The directions could simply say simplify, or the directions could say add, or combine, just to name a few. All right. So what do we have to do first? What do we have to do first? The first thing we need to do, my 3 stayed 3. The X stayed X. The 18, we broke it down. The 36, we broke it down. What do we mean by that? We broke it down. We looked at its factors. Factor first. We almost always got to factor first. Sometimes we got to get it equal to 0 first. There's no equal sign. Nothing to get equal to 0 here. So we want to factor. Factor your denominators for sure. Numerators, you don't factor till the end. We'll get into that later. Factor your denominators. Which denominator do you guys want to factor first? This one on the left, the quadratic trinomial, or this one on the right, the linear binomial? Does anyone have a preference? How about Asaya, Amelia, Ariel, Ella, or yeah, I picked all the vowel names. Can any of you tell me what my greatest common factor is for this over here? What's the greatest common factor? What do they have in common? Maybe Justin or Jabari. Go ahead, Asaya. What is it?
3.
Yeah, it's 3. So I'm going to factor out the 3. And if I factor out the 3, what's left inside?
X plus 1.
Thank you. X plus 1. Good. That denominator is factored. Those are the Skittles that this denominator has. They have a 3 Skittle and they have an X plus 1 Skittle. All right. X plus 1 Skittle, a 3 Skittle. What Skittles does this one have? Can anybody tell me what that is factored? We talked about AC method having that shortcut as long as the A is 1. AC method has the shortcut. A is 1. C is 4. What's 1 times 4? 4. But the SAT is going to try to trick you. They love the 1 away. They love it when the B is 1 away from the C because you're going to see 1 times 4. And what are people going to be like thinking? Their eyes are going to look here at the 5 and be like 1 and 4 makes 5. Common mistake. And they're going to mix up, like adding and multiplying because you're nervous taking this test. So be careful. But we said if A is 1, we could take a shortcut. We need it to add to give us 5. That'll be a positive 4 and a positive 1. So as our shortcut, we could just do X plus 1 and X plus 4. These are your children. These are your children. My 2 sons, Dylan and Jabari. Dylan and Jabari are being a little jealous of each other because one has something the other one wants. But they already have one thing in common. But over here, Dylan is jealous that Jabari has what in his denominator?
3.
A 3. He's like, I want a 3 too. And we're like, all right, Dylan. Here you go. You get a 3 on top. You get a 3 on bottom. And now Jabari's like, wait a minute. But Dylan has blah, blah, blah. What does Jabari want?
X plus 4.
Right. Jabari wants an X plus 4. Here you go, Jabari. We're on a budget, guys. We can't give you anything extra. We give you the bare minimum. So you guys have the same. We're budgeting over here, okay? We're saving up for something nice, okay? We're saving up for a Tesla. So when you get your driver's license, you don't have to drive. Your car will drive you. All right, common denominator, looking good. Now here's the thing. Don't distribute denominator. Don't distribute denominator. What's DDD? Don't distribute denominator. The denominator, we leave it factored, lovely, beautiful that way. Leave it alone. So cross, there's our denominator. 3, X plus 1, X plus 4. 1 times 3 is 3 plus, now nowhere did I say don't distribute numerator. I said don't distribute denominator. So if I distribute over here, what do I get? Maybe Manuel can help me. Sean. 5x times x plus 4. What do I get?
X squared plus 20.
5x squared plus, I couldn't hear.
20x.
Yes, plus 20x. Thank you, Adriana. All right, there we go. Next step, I'm going to clean up this numerator. I'm just going to put it in order. And we're going to think like, could I factor that numerator and see if we could go from there? But next step, I'm going to go standard form for that numerator. 5x squared plus 20x plus 3 over 3 x plus 1 x plus 4. Now, you would try to factor your numerator if possible. I'm going to tell us right now that we're not going to factor that. 5 times 3 is 15. What multiplies to give you 15 adds to give you 20. We can't get anything nice for that. So we're done. However, okay, so that is your answer. So you got to indicate the simplified answer. All right, but I also want to indicate what's R word am I about to write down?
Restrictions.
Good. Help me out with these restrictions. How many restrictions do we have? And what are they? X cannot equal. Sol, Sean.
If 3.
We don't have 3. We only actually have 2. We have 2 because it's what X cannot equal. So we only have 2. I think I heard 3. I wasn't sure if that's what I heard, but what are you thinking, Liana?
It can't equal 1 and it can't equal 4.
So close, but remember.
Oh, negative 1 and negative 4.
Better, negative 1. And I'll just write it out as 2 things. X cannot equal, I don't know why I crossed that way this time, sorry. Negative 4. Because remember, we can't divide by 0, so negative 1. It's always the opposite of that number in the parentheses. Keep that in mind about algebra when we did synthetic division, when we did the remainder theorem, when we did the x value of the vertex of a parabola. Every time we have this number in a parenthesis, it's always the opposite number, you know? So just keep that in mind. So those are the 2 numbers that if you fill them in for x, the bottom will have a 0 in a parenthesis, a 0 skittle. And if we divide by 0, no bueno, no answer. All right, so that's the end of this example. And we're going to write down a couple more for us to do right now. So next, let's look at...
Can you go back? I'm sorry.
Oh, sure. Anything for you, boo-boo. Oops, there's the problem. So we're going to do a couple more examples. And we're going to kind of really improve our factoring. So make sure you're ready to go with that. And we're going to go into solving. So this is like a double whammy over here. Double whammy kablammy over here. Ready? Can I flip now?
I'll just screenshot.
So you're good? I don't know if that means you did it already or you were about to do it.
Okay, I have the screenshot. You can flip.
Okay, you have it. Got it. All right, so solving. So we're building, rational. Now, what's the difference between solving and simplifying? What's the difference between solving and simplifying? When you see those words in your directions, what's the big difference?
The equal sign?
There's definitely an equal sign. And let's think about what the end goal is too. When you're simplifying, your end goal is going to be something that is simplified. And when you're solving, your end goal is going to be something that is solved. How do those things look different? How do those 2 things look different? When something is simplified, Think about what the answer to the last one looked like. It looks a little like the original problem, but more simple. When something is solved, your answer is going to be something like x equals blank, b equals blank. You get an answer, a final solution, all right? So we have two examples here, and I am going to give one more. So did you guys copy those down yet? I'm going to do one of them with you right now, but the other two you're going to finish for homework, or at least I'll start this one. So all three will be for homework really at the end of the day. But I just want to get one started with you. So let's do this over here. 5 over x plus 2 equals -1 over x squared plus 7x plus 10. And then minus 3 over x plus 5. Okay. So your directions on all three of these solve. We'll call them numbers 1 through 3. I know it was example 1 just a second ago. And that'll be 1, that'll be 2, and 3. And I'm going to just get started with you in this last minute right now. So we got about 30 seconds to wrap this up, okay? You want to look at your denominators, make sure they're factored. X plus 2 is already a prime factor. It's linear. We're good. X is already a prime factor. It's linear. We're good. That's a quadratic binomial. We can factor that. And when we can, you sometimes want to look at the ones that are already factored for a clue. How can I factor this denominator? I always start by looking for a greatest common factor. That was factoring method 1. What's the greatest common factor between the x squared and the 2x?
X.
It is x. If I factor out an x, what's left inside? We factored out an x. We undistributed.
X plus 2?
Yep, x plus 2. So that one has both an x and an x plus 2. This only has the x, and this only has the x plus 2. So when we're solving something like this, we want to make sure that they have a common denominator first. And there's going to be 2 ways to do this, exactly like there were 2 ways to do when we were doing the simple fractions at the very beginning of this unit here. What do I need to multiply my first fraction on top and bottom by? What do I need to multiply my first fraction right here on top and bottom by?
X.
Yes, it needs the x. So x on top and x on bottom. Getting closer to all the bottoms matching. And what does this one have to get multiplied on top and bottom by? The 1 over x.
X plus 2.
Yeah, x plus 2. Okay, so everyone's got the same denominator, but we have that equal sign, so we're going to have 2 sides to this. What am I going to write for my next step? I'm going to go ahead. I'm going to do x plus 2 is my common on the left. X plus 2 is my common on the right. My numerator, 2 times x, is just 2x. Minus, I don't have to write the 1. You can if you want. X plus 2, and that's -4. Now, when we're solving, 2 things we're going to do right now. We're going to distribute the minus, which is a -1. And we're going to drop our denominators right now because we have 1 on each side. This is something called the OnetoOne property. And we're just going to solve the tops. Because if the bottoms already are equal, in order for both sides to be equal, the tops have to be equal. Okay? So Paige, you want to ask your question while I distribute that minus sign?
I have so if the denominator is the same, wouldn't it cancel out?
Almost. We don't use the word cancel. It means 0.
But
That's why you kind of could think you ignore it. That's why we use this one-to-one property. Because it's like, well, those are already the same. You know? So it's like, let's not look at that. Let's just carry on and look at the tops. So it's we're going to get more into that next class to be more precise with how we describe it. So there, negative. I distributed that minus, and now we're almost done, guys. What's 2x minus x?
X.
That's just x. And let's add 2 to both sides. What's negative 4 plus 2?
-2.
Yeah. So, final answer. That big scary equation, x equals negative 2. What does that mean? That this equation that I wrote up here in black originally is true when x equals negative 2. Okay? You don't want to forget to check for restrictions though. So let's go back. Restrictions. What's x not allowed to equal? Maybe look at this denominator here. Two things. I see two numbers x is not allowed to equal.
-2.
Uh-oh. Yep. And what if it's just
X.
x can't equal
1. -1. 0.
0. Plus and minus 1 would be where the negative ones come from. Remember, you guys did this back then too, where when it was just x, you kept calling it like a 1 or a 1 or negative 1. And it was like, no, 0 when we were graphing polynomials. So if these are my restrictions, and I solved and that's what I got, guess what that means? It can't be negative 2, but that's what I got. So no solution. And we're done with this example. We will continue with this next class, but for homework, you're going to do these two the same way we did this. I'm going to upload this now. If I don't post it on Classroom right away, please look for it on my channel. If you just subscribe to the channel, you get like an alert, I guess, when I post something. Otherwise, just go look for it. I have a playlist with all rational function stuff, so you can look on the playlist, maybe save that, so that you at least can check that out. Okay? Have a nice day. I hope you come for extra help after school if you need some help.